Good day everyone, this is Engineer Freedom Karodan. So for this video, for this part of the video, I will discuss the same problem as our problem number 1, but this time I'm going to use conjugate beam method. Okay, so we have this problem. So by the analysis of conjugate beams, we have to first create a moment diagram. So I'm going to use the moment diagram by parts at fixicity dito sa point A, sa fixed support na dyan, okay? Okay, and so first is our concentrated, our reaction at B with respect to the fixed support sa A, okay? This should be the reaction times its distance with respect to fixed at A, that is 6 times RB. Okay, so for the uniform load naman, we have this, since this is a 0 degree, so sa shear niya naman is 1 degree, therefore our moment is a second degree curve. Okay, second degree curve. And then meron naman tayong formula dyan for second degree curve, WL squared over 2. Okay, so we will arrive with this answer. Okay, and then for the next part, you have to create our conjugate beam. Okay, so our moment at the real beam is going to be our load for our conjugate beam, and then we have to modify our supports, so it will look like this. So our conjugate beam should look like this. Okay, so yung moment natin under our real beam will be our loadings for our conjugate beam, and then we have to modify our supports since fixed ang ating support sa real beam. Therefore, kapag kinonvert natin siya for conjugate beam, it will be a free end. Okay? So, for simply supported naman, ganun pa rin naman siya for conjugate beam. Okay? So, kung mapapansin nyo, as I have discussed previously in our topic sa school, that when we convert our real beam under statically determinate beams, ang real beam, ang simply supported, ang ating statically determinate beams, when it in terms of conjugate beams, it should be always statically determinate beams pa rin. So kapag naman statically indeterminate beams ang i-convert natin to conjugate beam, that should be a unstable na beam. So nakikita nyo naman, from statically indeterminate naging unstable. Okay? And then, since iisang support na lang naman yan, so wala tayong magagawa kundi to take summation at point B is equal to 0. Clockwise is equal to counterclockwise. Okay? Okay. So, take natin yung taas ng triangle. 1/2 times 6 na base times height na 6 RB. And then, we have its moment arm. So, probably andito yung kanyang centroid. 2/3 times 6 meters. Okay? And then we have counterclockwise na moment. This is second degree curve. Okay? 1/3 times 6 times 450 times 3/4 of 6. Dito yan. And then we have the so, yun lang pala. Okay? So, therefore, isang variable lang matitira dyan. So, yan yung ating masasolve. So, RB is equal to 56.25 kilonewtons. So, kung i-compare natin siya sa ating previous na methods, same lang ang nakuha natin. Okay? So, solving for our remaining reactions. Okay? Ngayon ko muna yung moment at A is equal to 0. Okay, we have clockwise equal to counterclockwise. Therefore, 25 times 6. Kanina dito. Ayan. 25 times 6. And then, times its moment arm 3 is equal to RB 56.25 times 6 plus the moment at A. Therefore, our moment at A should be equal to 112.5 kilonewton meter. So, pacheck na lang kung tama yung mga sinusulat ko. And then, for our remaining upward force na RA, we can solve it using the summation forces vertical. Okay? 56.25 na RB. And then, our reaction at A minus our downward force na uniform load. Therefore, RA should be equal to 93.75 kilonewton. Okay? So, kung papanoorin natin yung part 1 ko, our action is just the same. And then, solving for shear and moment, same lang. Ganun pa rin yung process natin. Solving for the maximum shear and the maximum moment. So, ang next na di-discuss ko is the shortcut method for common types of distributed, common types of loadings for our prop beam. Okay? So, sa sample na to, we're going to use the same problem for the first problem na diniscuss natin. Okay? So, kita nyo dyan that we have a uniform load in a prop beam. So, very common lang siya. Okay? So, meron na siyang nagawang shortcut na formula in determining the reaction at A, reaction at the fixed support, reaction at the roller support, and the moment at that fixed support. And then, meron na rin siyang derived formula for the shear and moment at every parts of the beam. Okay? So, isa-isa kong ilalagay. For the fixed, the moment at that fixed support, ang given formula niyan is WL squared all over 8. Okay? So, fixed support yan na. And then, kapag naman sa reaction at that fixed support, we have 5 over 8 WL. So, ginagamit ito usually for design subjects since we are dealing with common lang naman na loadings for our structure. Okay? So, since we are discussing structural theory, mas maganda pa rin na sundin natin yung ating method for solving na yung most typical na method na ginagamit natin is the long method. Okay? For analysis. So, ito is for common types of loadings lang. So, makikita nyo naman dyan na isa lang yung nakapatong sa ating beam width is the uniformly distributed load. Okay? And then, for the reaction at B, we have 3/8 times WL. Okay? So, susubukan natin ito mamaya. Let us put in the shortcut formulas lang for our problem. Okay? So, kapag naman dito sa part na to, obviously, tumaas ang ating shear ng 5 over 8 times WL. And then naman, kapag ito, bumaba siya ng, wait lang, this is supposed to be a length. And then, kapag solve naman natin to, we have negative 3/8 WL. Since dapat kapag nagpataas tayo ng reaction na revert WL, magsasarado ang ating shear diagram. Okay? So, solving naman for the length of this part, simply, this is just 5 over 8 times the length. So, this part naman, 3 over 8 L lang. Okay? So, very basic lang kapag nalaman natin siya for common types of loadings lang. Okay? And then, for the moment diagram naman, So this part sa left side of our beam, which is under the fixed support, our fixed support at the left side, we have the moment here, the WL squared. Since counterclockwise yan, WL squared over 8. Okay? And then, for the maximum moment here, for this type of loading, meron na siyang binigay na formula, which is 9 over 128 WL squared. Pero mas maganda pa rin na alam natin yung ating method na where we analyze our problem for complicated na loadings na. Okay? Kasi at the end of the analysis, ganun pa rin na makukuha nyo. At mas madali na kapag naintindihan nyo lalo yung kanyang concept. Okay? So for this part, isosolve ko na lang din tong part na to using these formulas. Okay? Same problem. So, wait lang. So, ayan yung ating loadings. Okay? 25 na uniform load and the length. So, solving the reaction at A using this formula, 5 over 8 times 25 times 6 is equal to 93.75 kilonewton. Check natin kung tama. So, RA, 93.75. So, tama for our reaction at A. And then, moment at A naman, okay, nakalagay dyan na WL squared over 8. 25 times 6 squared over 8. Our answer is equal to 112. 112.5 kilonewton meter. Okay, solving naman for the reaction at B, we have 3 over 8 times 25 times 6 is equal to 56.25 kilonewton. Okay, kapag chinek natin dito, our answer is correct. Okay? And then, so, tama na to, itong formula na to. Okay? This is correct. Tandaan nyo na lang kung gusto nyo. But, I recommend na sundin nyo pa rin yung mas mahabang analysis. Okay? So, for our shear naman, okay, 5 over 8 over WL. So, same lang dito sa ating RA. Therefore, this is also equal to 93.75. And then, dito naman, 3 over, negative 3 over 8 WL. Same lang sa ating reaction at B. Therefore, negative 56.25 kilonewton. Okay? And then, solving for the length dito. Okay, so we have 5 over 8 times 6, that should be equal to 3.75 meters. And then for this part, 3 over 8 times L. Okay, 6 minus 3.75 lang. Okay, let's use that formula. 3 over 8 times 6. We have 2.25. Okay, so tama naman siya since magkakaroon siya ng length na 6 meters. So, let us compare later for our solved shear and moment diagram sa ibang methods. Okay, so next, so moment na diagram. Okay, so same lang naman yung moment dito and our moment dito sa moment diagram. So, yun yung moment at A. And then we have 112.5. So, moment naman dito, moment here, solve ko dito. So, 9 over 128 times 25 times 6 squared. Our answer should be 9 over 25 times 6 squared. Our answer is equal to 63.12. 63.98. Okay. And then, getting our maximum shear. This should be, compare nyo yung dalawa, our maximum shear is 93.75 kilonewton. And then for the moment naman, our maximum positive moment is equal to 63.28 kilonewton meter. And then for our negative maximum moment, our answer is equal to 112.5 kilonewton meter. Okay, so let's check kung tama yung mga sagot natin. So this is our answer from this was our answer from our previous na methods that using area moment and double integration moment, we arrive with this answer. Our maximum shear is equal to 93.75 and for the maximum moment 112.5. Okay, so tama naman. Okay, check ko lang to. Kapag tinanong is the maximum moment, let's take the absolute value of this moment. Okay, so mas mataas yung 112.5 kilonewton meter. So this is our answer. So comparing dito 93.75, 112.5. So tama yung ating sagot for this formulas for common loadings. So nakuha natin yung maximum shear end moment using this formula and the concept of the deflection method. So ayan, I hope na may natutunan kayo sa example na to. So for the next part of the video naman, I will discuss for more problems regarding prop beams. Okay, so abangan niyo yan and thank you for listening.